Welcome to 6.2. We're going to be multiplying and dividing expressions. So this is going to use a lot of from what we did in the first lesson where we were like simplifying, factoring, we were looking for greatest common factors. It's just kind of an additional step here when you're multiplying and dividing, and I'll get to that in a second, but let's do a little warm up. So remember, if you see 3 or 4 terms, in this case, 1, 2, 3, 4, and it's a cubic equation, that's probably going to lead to a box method problem. So you just line them up in order. It'd be x cubed, 2x squared, negative 4x, negative 8, and then we do the greatest common factor. So x squared, negative 4x, and then a 2. All right, so I'm just going to rewrite this here. I'm going to change my pen color. So this is the same as x squared minus 4 over x, or x plus 2 on the top. Now this bottom one will also factor, so we can take out an x plus 2 and an x plus 2. Factors of 4 that add to make 2. Now note, I can go ahead and cross this out because I have one of each on the top and the bottom, but remember that x squared minus 4, that'll simplify a little further. So that's x plus 2 times x minus 2, and then I still have this x plus 2 on the bottom. So I'm going to cross that out, because I see that one more time, and now I recognize that x minus 2, that's the last piece that I have, and that's completely fine. Let's do one more of those. So this one's going to be one where it requires the cross section. 6 times 14 is 84, and then 20. Yeah, I think I did that one right. So factors of 84 that add to make 20 are 8 and 12. 8 times 12 is 84, 8 plus 12 gives us 20. So then I can do the box method here. 6x squared, 14, 8x, 12x. Then I would get 2x here. I'd get a 2, 6x, and a 2. Something doesn't seem right though. Should be able to take a bigger factor out of those. Okay. So I didn't take out the greatest common factor. And I knew that because when I took 2 times 2, that doesn't make 14. So I should have factored out a 2 right away. I'd be left with 3x squared plus 10x plus 7. Okay. So I would have to change this up. That's why it's good to double check your work. So then I would have factors of 21 that add to make 10, which are 3 and 7. Try that one more time. So then I would have a 3x squared in this first box, a 7 here, 3x, 7x, we'd get 7, 1. This would be x, and this would be 3x. Okay, that makes a lot more sense. So I'd have a 2 on the outside, an x plus 1, and a 3x plus 7. Over the bottom, I can factor out a 2x, and then I would have x plus 1. Be really careful. I know it's weird, but when you factor 2x out of itself, you're still left with 1. Any number divided by itself is 1. So in this case, 2's are going to go away, x plus 1's are going to go away, and we're left with 3x plus 7 over x. All right, on to multiplying the rational expressions here. So there's kind of 2 ways to approach this. I would suggest multiplying out your top and your bottom before you try to simplify everything. So let's just do 3 times 25, which is 75, and then we would have x squared on the top. I probably should have reviewed this, but when you're multiplying fractions, so if I have like 1/4 times 2/3, it's top times top, bottom times bottom. So that's 2 over 12, which we know will reduce to 1/6. So even after we multiply, we're going to be able to reduce. So here we have 5 times 9, which is 45, and then we have x times y, which we just put those side by side. Now, this turns into a problem like what we were doing in the previous lesson. So now look for numbers that divide into 75 and 45. We know that 5 divides into both of them. So if we divide each of them by 5 or cross out take a factor of 5 out, we'd be left with 9, and then 75 divided by 5 is 15. And then we can also take out an x. I'm going to get rid of the squared. So I'd have 15x over 9y. Now note, I did not take the greatest common factor out. I forgot that 15 goes into both of them. So what I can do instead is just go one step further. So take a 3 out of each of these. I'd be left with 5, 3, and my final answer is 5x over 3y. So even though I messed up at the beginning, I forgot to take the greatest common factor out. As long as you notice it as you're going through, you're still going to get to the right final answer. Okay, here's our next problem. Now we're dividing. Dividing is a little different. So let's take that same problem, 1/4 and 2/3, like what I did before. If I wanted to divide by 2/3 though, what I end up doing is you multiply by the reciprocal of the second term. It's the keep, change, flip is the phrase. So I keep the first fraction the same. I change my sign to multiplication, and then I multiply by the reciprocal. That's the flip part. And the reciprocal is just to take that fraction and flip it upside down. So now it turns into multiplication. So it's 1 times 3, 4 times 2, and I get 3/8. A completely different answer than what I got before. And this one doesn't simplify. So in this case, we just want to change this to multiplication. So let's keep that first fraction exactly the same. Let's keep that as 6x squared y to the third. Rewrite that a little nicer. 4x to the fifth. And now I'm just going to switch these two. And I want to change this to multiplication. So 8y to the third goes to the top. 3xy to the sixth. Okay. Now, I'm going to show you an alternative option for reducing specifically with the numbers. The variables, I would just combine those. Okay. So what you can do is note that we have 6 and 3. I have a 6 here and a 3 here. I know that 6 and 3 have a connection. I also know that 8 and 4 have a connection. So I could multiply these together and then simplify, or I could tell myself, well, I know that 4 is going to go on the bottom with this fraction, 8 is going to be on the top. So why don't I just do a little cross reducing? 4 goes into 8 once, and 4 goes into 8, or sorry, 4 goes into itself once, 4 goes into 8 twice. 3 goes into itself once, and 3 goes into 6 twice. So then I would have a factor like that. Now what I would get is 2 times 2, because I'm just taking these two together, which is 4. And then I have x squared. And we haven't seen this instance yet, but y cubed times y cubed, you have seen it before. You just add the exponents, so that becomes y to the sixth. The bottom, I have x to the fifth, and then I have a lone x here. I could put the 1s, but those don't matter because it's just 1 times 1. So this would be x to the sixth because I'm adding those exponents, and then I have y to the sixth. And now I just got to reduce, and you already practiced this before, so look for your common terms. So y to the sixth goes away because I have the same thing on the top and the bottom. And since I have 2 x's on the top, I'm going to be left with 4 on the bottom. So my final answer is 4 over x to the fourth. Okay, we're going to do a little bit more here. So now we're going to get into some of the factoring that gets to be intense. We've seen it in the past. Sorry, I just had to look at how many problems I had here. Whenever you are multiplying where something's a fraction, so like here we have a fraction, whereas this expression, this is not yet a fraction. Remember, you can always put it over 1 and change it into a fraction. Now, 27x cubed plus 8, if you remember, that is the formula a cubed plus b cubed. I'm going to write this down, and you might want to note this here or copy this onto your homework. That's a plus b, and then a squared minus ab plus b squared. So we've seen this before. It's just taking those old concepts that we have. And when we ever see 27 and 8, so it's 27x cubed, that comes from 3x, 8 comes from 2. So then this is going to become, I'm going to rewrite this. I'm going to keep the x plus 2 on the top, but the bottom is going to be 3x plus 2 times, and then it's 9x squared, because I have to square the 3. I'm just following this formula, minus 6x plus 4. And this problem was specifically designed because if we look at the other part here, 9x squared minus 6x plus 4, we could have tried to factor that and we would have failed because it's not factorable, unfortunately. But since we see that we're going to have one on the bottom, one on the top, we can just do that cross simplification and cross those out ahead of time. Okay, that looks like it's the only stuff that's going to go away because the x plus 2 doesn't have anything to go with. 3x plus 2 is not the same as that. We can't cross off anything out of these. So that's our final answer right there. Okay, here we have another division problem. Always note that, so if you want to rewrite, I'm going to first factor this one so I can take a 4 out of 4x and 8. Always look for that greatest common factor. Change it to multiplication. And now I'm just going to do some factoring along the way here. I know that x squared plus x minus 6, factors of 6 that have a difference of 1 are 3 and 2. So I'm going to go with x plus 3 and x minus 2. Now this top part here, I could have done this at the beginning, but this factors into x times x plus 3. I'm just going to put that on the bottom. All right, and now I'm just looking for stuff that I can cross off. I do see that I have an x plus 3 on the top and the bottom. I got an x minus 2 here and here. And then we're going to be left with 3 over 4x. So it didn't look like we were going to get anything close to that in the beginning, but sometimes you never know with these. They can even simplify down to a single number where there's no variable left. All right, and our last problem here. I always want to throw a 1 underneath anything that's not a fraction. And then take note, we have a division sign, so we got to remember to flip just the last part. It's always the term after the division sign. So let's keep everything else the same. We'd have x over x minus 2 times 2x plus 3 over 1 times the top part x minus 2. We can't take anything out of that. I'm going to put all of these in parentheses. And then 4x squared minus 9, this actually does factor because it's perfect squares. So it's 2x plus 3 and 2x minus 3. So I'm going to write those out, 2x plus 3, 2x minus 3. And you kind of know you're on the right track with factoring because we see a lot of stuff that's going to go away. So we see x minus 2, we see 2x plus 3 goes away. And then the only thing I have left on the top is this lone x. And then the bottom, it's just 2x minus 3. And that is our final answer. Looks like that's it for this one. Remember, for the multiplication, factor, and then you can do that cross simplification. With division, keep, change, flip. Don't forget to flip the fraction following the division sign.